Good afternoon, everyone. I, Dr. Savita Devkar, on behalf of Pimpri Chinchwad University School of Pharmacy, extend a very warm welcome to all respected faculty members, students, researchers, and esteemed guests who have joined us for today's enlightening session. Before we proceed further, it is my privilege to invite a respected Dr. Patil sir, head of the School of the Pharmacy at Pimpri Chinchwad University, to formally introduce the School of Pharmacy and share a few words about the university's mission and vision in shaping the future of pharmacists and researchers. Dr. Patil sir has been guiding force behind several academic initiatives and continues to inspire the excellence through his leadership. Sir, we kindly request you to address the gathering. 1 minute, sir.
Madam, am I audible? Yes, sir. Okay, okay. So anyway, now I'm going to start my lecture. Uh, the students and teachers who have joined this webinar, they shall get something new in my lecture. And let me tell you firstly what is the new thing in my lecture. Each and everything present in this universe has got solubilizing power. Up to this time, we know from the books and literature that only the liquids, the substances which exist in liquid state at room temperature, they are known as solvent. But today you will see the solubilizing power of not only liquids but also gases and solids. And particularly, we shall utilize the solubilizing power of solids to replace harmful organic solvents. So, through PowerPoint presentation, I would like to this give the details of all the solubilizing power of solids. So, let me start the sharing. अभी अपने थोड़ा नहीं है तो अभी इसको ढूंढने में टाइम लगेगा मिनिमाइज करना चले ये भी मिनिमाइज कर रहे हैं और एक बार इसको क्या हुआ ढूंढ रहा था मिल ही नहीं गया इसलिए इसको कर दे चलिए फूल लेना पड़ेगा तब जाके उसको ज्वाइन करेंगे Yes, I am waiting for the opening of the presentation. इधर आ जाएगा ना ये ओपन ले लेंगे क्या करें ऑफिस पर चले हाँ हो गया ओपन प्ले पर चले पहले इसको मिनिमाइज कर दें ये इधर आ जाएगा अब इसको करें चलिए okay, so now I'm going to share my slides. Respond कर सकते हैं is it visible में भी जाती है वो कैसे जाती है कहीं से मैडम is it visible तो एक बार बोला ना बिल पे क्या नाम है है अच्छा आवाज क्यों नहीं आती okay so now this is the topic more or less the same topic of today's lecture that is solubilizing properties of solids and replace harmful organic solvents Now, where these organic solvents are involved, which we have to substitute by the solubilizing power of say are impact in various analytical techniques like TLC, HPTLC, HPLC, UV analysis, cytometric analysis, etc. Also, these organic solvents are involved in the extraction of active constituents from herbal powders. Also, these organic solvents are involved in the synthesis of organic compounds, and also they are involved in the formulation of pharmaceutical dosage forms. इसको फुल स्केल को कैसे करते हैं इसको इसको पूरा देखेंगे एक्सपांड करते हैं इसको हाँ ऐसा ये ठीक है सो कैसे उधर की आवाज क्यों नहीं आ रही हेलो नाउ इज इट विजिबल ना स्लाइड्स आर विजिबल स्लाइड्स आर विजिबल आंसर नहीं आता है आवाज नहीं आती उधर अच्छा कोई बोल नहीं रहा होगा ओके मैडम तो फोन लगा के पूछना पड़ेगा तो कोई आवाज तो क्यों नहीं आ रही मैडम जब मैं कुछ पूछता हूँ तो मेरे को कोई आवाज नहीं आती है तो नहीं सर एक्चुअली कैसे आवाज नहीं आएगी क्योंकि बच्चों को अनम्यूट किया है नहीं लेकिन आप लोग में ऐसे कोई ना कोई तो होगा ना उसमें जो उत्तर दे सकता है अच्छा अच्छा ठीक है अच्छा ओके ओके हाँ तो इसी तरह हमारी चीज तो नहीं छुपेगी उसमें पूरी प्रोसेस नहीं करेंगे इसको आप साइड में रख सकते हो ड्रैगिंग प्रोसेस क्या करके इसको आप इधर उधर खिसका सकते हैं ऐसे करके कैसे क्लिक करके ऐसे है ना ये बनी के करोगे अच्छा जब जरूरत पड़ेगी तो थोड़ा उसको ले लगेगा ऐसा ठीक है ओके नाउ अब एक जन यार कोई इधर बैठ गया यार कोई एक जन रहा तो अच्छा लगता थोड़ी थोड़ी अल्टा पलटी करना बहुत होता है ओके now okay now I'm changing the slide so these I have told that here in these various fields organic solvents are involved now why do we want to replace organic solvents by solubilizing power of safe and economic solids the important reason is the long term use or the long term exposure of these organic solvents vapors. It may cause serious effects such as neurological disorder, chronic renal failure, liver damage, and so on and so forth. So these are the harmful effects of vapors of organic solvents. All organic solvents they are volatile, so that's why whenever we deal with them, when we do work with them, the vapors come inside our body, human being. Now, whereas organic solvents, they can be kept in three broader classes of organic solvents: class 1, class 2, and class 3. Class 1 organic solvents are most harmful for human being as far as the hazardous issues are concerned. For example, as you are seeing in the slide, benzene is carcinogenic, carbon tetrachloride is also very harmful for from the point of view of health and all that. Class 2 organic solvents commonly implied their acetonitrile, chloroform, toluene, pyridine, hexane, diethylbromide, etc. The toxicity of these class 2 organic solvents is little bit lesser than that of class 1. Class 1 have got most, they are most hazardous to our health. Class 3 organic solvents commonly implied they include acetic acid, acetone, ethyl acetate, etc. Among the three categories, class 3 organic solvents are safer. Now coming to the future role of solvent character of solids, solubilizing power of solids shall minimize the use of harmful organic solvents in future. Class 3 organic solvents are relatively safer than class 2 and class 1 organic solvents. We can potentiate the solvent power of class 3 organic solvents to act as class 2 and class 1 organic solvents. Now what happens in dissolution, let us understand. Dissolution of a solute in a solvent involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. For example, suppose we dissolve, say, metformin hydrochloride drug in water, we get a clear solution. The reason or mechanism by which we get a clear solution of metformin hydrochloride in water is as a result of weak van der Waals forces and hydrogen bonding between the warm uh, molecules of solute. Solute means metformin hydrochloride and molecules of solvent means water. Means always there are physicochemical interactions between the molecules of solutes and molecules of solvent. Suppose you are dissolving something in ethanol, say for example, salicylic acid in ethanol, we get clear solution. The dissolution of salicylic acid in ethanol takes place as a result of physicochemical interaction between the molecules of solute means salicylic acid and molecules of ethanol solvent. So just like this, as means this is the simple mechanism of dissolution of solutes in solvents like that. Okay. Now I have started very new concept known as mixed solvency concept, first time in the world, and that says that is mixed solvency concept of mixed solvency concept which was proposed in the year 2009. So there are two parameters of this concept. First parameter of this mixed solvency concept says that each and everything present in this universe has got solubilizing power. Each and everything means whether the thing is gas, the thing is solid, thing is liquid, okay. But now indirectly, what we can say that gases, solids, liquids, all molecules, whatever are the number of molecules present in this universe, all molecules possess solubilizing properties. Number one, all molecules present in this universe they are known as solubilizers. For example, as in case of liquids, all substances present in liquid state at room temperature are known as solvent. Water, ethanol, methanol, fluid. But whatever the name of any solvent you say, they, for example, you say water is solvent, but water is good solvent for some solutes and bad solvent for other solutes. One third drugs they are water soluble, two third drugs water is soluble. So we can say whatever the name of any solute you take, whether it is fluid or methanol, any solvent, that solvent possesses good solubilizing power for some solutes and bad solubilizing properties for other solutes. In mixed solvency concept, I told you that whatever are the number of molecules present in the universe, all molecules possess solubilizing properties. And they are known as solubilizers. For example, CO2, solubilizer, paracetamol, solubilizer, ethanol, solubilizer. All molecules are solubilizer. But whatever the name of any solubilizer you take, that solubilizer possesses good solubilizing power for some solute and bad solubilizing power for other solutes. Now, if I say that all gases also have got solubilizing power, how? You see, for dissolution, a liquid state is required. How? We can dissolve metformin hydrochloride in water. Because in water, liquid water, water molecules, they are in movement. Water molecule in liquid state, they are in movement. So these molecules which are in liquid state, they can be involved in hydrogen bonding and weak one of the forces. But you cannot dissolve metformin hydrochloride in ice. Why in ice also there are water molecules? Then why you cannot dissolve? The reason is in ice the water molecules they are stagnant, and in the molecules when they are stagnant they cannot be involved in hydrogen bonding and weak one of the forces. So what I want to tell you for dissolution to take place, आपको खाना खाने जाना पड़ेगा तो सुबह तो मैं आ जाऊंगा बुलाने कॉल कर दीजिए हाँ एक बार मैं कॉल करके छोड़ दूँ okay so what I was saying that for dissolution the liquid state is needed. If I say that CO2 is solubilizer, but when not you are not going to dissolve something in CO2 gas because molecules of CO2 should be in liquid state. So there is one technology known as mixed this supercritical flow technology, which is there in which is running from years. And in supercritical flow technology, CO2 gas at a particular pressure and temperature, it is liquefied. It means CO2 is liquefied, and this liquefied CO2 is used as solvent to carry out different functions by supercritical flow technology. We prepare nanoparticles after dissolution of drugs in liquefied CO2 in supercritical flow technology. We perform the extractions of active constant from rubber powders and so on and so forth. So ultimately, a gas means CO2 after liquefaction. When the molecules of CO2 they are in liquid state, they are in movement. Now this liquefied CO2 is being used as solvent to carry out these functions and all that. Okay. So this is one way. Means if you liquefy any gas, it will be at acting as solvent and all that. But anyway, now coming to mostly in my lecture, I will give the applications part of solids, solubilizing power of safe and economic solids. So I'm going to give the proof that how can we say that solids have got solubilizing power. So now how a solid can give its solubilizing power when the molecules of a solid come in liquid state. As I told you that you cannot dissolve metformin hydrochloride in ice, but you can dissolve in water. Similarly, if you means if the molecules of a solid come in liquid state, so that they are in movement, so that these moving molecules of solid can be involved in physicochemical interaction for the dissolution of solutes. So there are three ways by which the molecules of a solid may come in liquid state. Number one, by melting. If you melt a solid, molecules come in liquid state. Number two, by dissolution in a solvent, the molecules will come in liquid state. Number third way is eutectic formation. All these examples I will give briefly. Okay. Uh, so, firstly, the examples of melting. Then I will discuss the proofs that how can we say that solids possess solubilizing power. Please do not relate with formulations and all that. Okay, just we have to see the proof. How can we say solids possess solubilizing power? So here I will give one example here that if you take a test tube, 1 gram urea, if you put in that 1 gram urea crystal, the melting point of urea is 132 degrees centigrade. If you heat this test tube on heating mantle at 132 degrees centigrade with the melting point of urea, you will get 1 gram clear colorless melted urea liquid, which can be shaken like any solvent. So now in your test tube, there is 1 gram clear colorless melted urea liquid in which the urea molecules are in liquid state. And this 1 gram clear colorless melted urea is very good solvent for dichloromethane sodium. Melting point of dichloromethane sodium is 283 degrees centigrade. So when it gets dissolved, it does not melt here. So what I want to say, 1 gram clear colorless melted urea at 132 degrees centigrade nicely dissolves 1 gram of dichloromethane sodium. A clear solution is obtained. Why you are getting a clear solution here? There is no solvent, no chloroformethanol, methanol, etc. Who is dissolving this dichloromethane sodium? So the molecules of urea, they are in liquid state, they are in movement, and these molecules of urea are involved in physicochemical interaction with the molecules of dichloromethane sodium for the dissolution. So this is the example. Anyway, now briefly I will go only few examples only. Then I will do the application part of solids so that the B Pharm second year, third year, final year students they can do some research work based on this hydrotropic green technology and all that. So I will cut short this part, means the proof. Now, second way by which the molecules of a solid may come in liquid state. Why we wanted the liquid state of solids molecules? So that these molecules which are in liquid state in movement condition, they can be involved in the dissolution of other solutes. Anyway, one example I will give here that of ibuprofen. Ibuprofen has got poor solubility in water at room temperature. As you are seeing, it is the 0.028%, very poor solubility with by volume. 0.028% is the solubility of ibuprofen in water at room temperature. Now, you see in this condition also the hydrogen bonding weak bond forces they are taking place. But the extent in between ibuprofen molecules and water molecules. But the extent of hydrogen bonding and weak bond forces is poor in between ibuprofen and water molecules. That's why there is poor solubility. So anyway, so now what we have got, there is poor solubility of ibuprofen in water. Now we will prepare a solution of a solid, sodium benzoate, 28.8% weight by volume, 100 ml volumetric flask, 28.8 gram of sodium benzoate, water, dissolution, volume makeup up to the volume 100 ml with water. So this 100 ml of the solution contains 28.8 grams of sodium benzoate. We say concentrated solution of sodium benzoate is this one. Okay. In this solution of sodium benzoate, when we check the solubility of ibuprofen, that is 2.390%. 2.390%. Means how many times, how many fold enhancement in solubility is there? 2.390 divided by 0.028. About 85 fold enhancement in solubility is there. Now, why solubility has been increased? The reason is here the solid sodium benzoate, when it is dissolved in water, the molecules of sodium benzoate come in liquid state and they are in movement. They are means sodium benzoate molecules. And because of these sodium benzoate molecules which are in movement, these molecules of sodium benzoate, they are associated with hydrogen bonding weak one or forces with the molecules of ibuprofen for the dissolution. So here what we are observing, solids possess solubilizing properties because they are the molecules which have got right to make hydrogen bonding with one of our forces. So these molecules may come from gas, may come from solid and all. Anyway, one more example let me discuss. Furosemide or furosemide has got poor solubility in ethanol at room temperature. Sparingly soluble, 1.7% poorly soluble due to poor extent of hydrogen bonding and with one forces, producing the molecules of ethanol and molecules of furosemide. Now, if we dissolve a solid, niacinamide, or in other words, it is also known as nicotinamide. If you prepare 15% weight by volume solution of nicotinamide or niacinamide in ethanol, in this solution, the solubility of furosemide is about 5%. 5%. And in ethanol only it is 1.7%. So threefold advancement in solubility is there. Why solubility has been increased? Because in 15% niacinamide in ethanol solution, the molecules of nicotinamide or niacinamide, which is solid at room temperature, but when it is dissolved, the molecules of niacinamide they come in liquid state and they are in movement, and these molecules of niacinamide they take part in this physicochemical interaction with the molecules of furosemide for the cellular solubility. So these all are the proof. Don't relate with formulation. Third way by which the molecules of a solid may come in liquid state or what, so that they can demonstrate their solubilizing power is by eutectic formation. This is the third way. Melting solution and third is eutectic formation. Suppose you take 5 gram thymol, 5 gram menthol in crystal water, you triturate then you will get a clear colorless eutectic liquid of methyl thymol. It is clear colorless liquid just at room temperature. It is just like a solvent, because it can be taken like any solvent. In this condition, in liquid state, the molecules of menthol and molecules of thymol, they are in liquid state, they are in movement. And now I am giving some examples of solubility enhancement by this eutectic liquid. On left hand side, if you see number one is metronidazole benzoate. Metronidazole benzoate is a very poorly water soluble drug, very poorly water soluble drug, water insoluble type of drug. Okay, but in this particular eutectic liquid of thymol menthol, 1 ml, in 1 ml you can dissolve even 200 milligrams of metronidazole. About 20% solubility is there. Who has dissolved this metronidazole benzoate? This eutectic liquid does not contain any solvent, ethanol, methanol, chloroform, but only thing is the molecules of menthol and thymol they are in liquid state, and these molecules of menthol thymol they are involved in hydrogen bonding and with whatever forces the molecules of metronidazole benzoate dissolution. On the other hand, if you see the cetronidazole is very poorly soluble in this, even 5 milligram cannot be dissolved. So for cetronidazole, this eutectic liquid is bad, poor solvent, just like the so-called solvent, water, good solvent for some, bad for other. Chloroform, good solvent for some, bad. Similarly, this eutectic liquid is good solvent for some left-hand compound, metronidazole, benzoyl, or arnidazole, etc. And it is bad solvent for the cetronidazole, etc. So now you can say this eutectic liquid is a solvent. And once you say it is a solvent, it means that solvent, whatever it is having, must possess solubilizing properties, and it is a proof that menthol and thymol molecules have got solubilizing power. So these all were the proof. Now we are coming to the utilization of this solubilizing power of solids to replace harmful organic solvents. So before it's a discussion now, the B Farm students, please now listen this 100-year old concept known as hydrotropic agent. Okay, hydrotropic solubilization. Maybe that you might have read something about the hydrotropic solubilization also. Anyway, so what is this hydrotropic solubilization, which is more than 100 years old concept? Now you see, in this slide, you are having a list of hydrotropic agents. So now I am discussing, I am giving few examples of hydrotropic solubilization. From this list, from nearly from the middle, if you see it is urea. So urea is also one of the hydrotrophic agent. Now I am giving an example of dichloroflex sodium. Dichloroflex sodium drug has got poor solubility in water at room temperature. What is the solubility? 1.6% nearly 1.6% at room temperature in water. Dichloroflex sodium. Again, the reason is same due to poor extent of hydrogen bonding and weak one-over forces between the molecules of dichloroflex sodium and molecules of water. Okay, now, so ultimately it is a sparingly soluble drug. Now we are going to prepare a concentrated solution of urea in water. 60% weight by volume solution, 100 ml volumetric loss, 60 gram urea crystal, water, clear solution up to the mark 100 ml. This 100 ml of the solution of urea in water contains 60 grams of urea. And since you are getting the solution of urea in water, this urea molecules they are not in liquid state and they are in band. Okay. Now, when the solubility of dichloroflex sodium is checked in this particular solution, concentrated urea solution, 60%, the solubility is at 4.8%, nearly 5%, you say. About threefold enhancement in solubility there, threefold enhancement. Why enhanced solubility has been enhanced? The reason is the molecules of urea have come in liquid state and movement, and these molecules of urea are involved in physicochemical interaction with the molecules of dichloroflex sodium for its solubility. Okay, so this is one example of hydrotrophic solubilization. Why is hydrotrophic solubilization? Hydro means water. When the solubility enhancement is there in water or in aqueous solution, then it is related with hydrotrophic solubilization. Hydro means water, solubility enhancement in water. Okay, so this is one example of hydrotrophic solubilization, which is more than 100 years old concept. Anyway, now another example from left side, sodium citrate. Now the solubility of salicylic acid in water is poor at room temperature, about 0.3%. 0.3% is the solubility of salicylic acid in water at room temperature. Weight by volume of poor solubility due to poor extent of hydrogen bonding with one over forces between the molecules of salicylic acid and molecules of water. Anyway, so salicylic acid has got poor solubility in water, 0.3%. Now we are going to prepare a concentrated solution of sodium citrate in water. 45% solution we are going to prepare. 45 gram sodium citrate, 100 ml volumetric loss, 45% weight by volume solution in water. In this solution, the solubility of salicylic acid is more than 15, more than 15%. So 15 divided by 0.3, 50-fold enhancement in solubility. This is another example of hydrotrophic solubilization. And why it is hydrotrophic solubilization? Because we are going to increase the solubility of a poorly water soluble drug salicylic acid in aqueous solution of sodium citrate. That's why it is hydrotrophic solubilization. Now, the reason for solubility enhancement, the sodium citrate molecules have come in liquid state after dissolution. And these molecules of sodium citrate which are in movement in this solution, they are associated with weak van der Waals forces with molecules of salicylic acid product dissolution. Okay. Another one more example we will take first, a sodium benzoate from this list. Sodium benzoate is also very good hydrotrophic agent. If we prepare a concentrated solution of sodium benzoate in water, so for example 30% weight by volume, in this concentrated solution of sodium benzoate, the solubility of several poorly water soluble drugs is enhanced. Now I am naming those poorly water soluble drugs of which the solubility is enhanced by sodium benzoate solution concentrated solution. Ofloxacin, betifloxacin, pindazole, metronidazole, naproxen, flurbiprofen, ketoprofen, naproxen, nalidixic acid, and so on and so forth. A large number of poorly water soluble drugs have very good solubility in sodium benzoate solution. These all are the examples of hydrotrophic solubilization. Hydro means water. I told you that. Right? So here two words are important. Poorly water soluble drugs solubility will be enhanced with the concentrated solution of hydrotrophic agent. So now here the definition of hydrotrophic solubilization is this. When you see these, I told you this slide gives the examples of hydrotrophic agent. When there is enhancement in aqueous solubility, this is the now definition. of hydrotrophic solubilization. When there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, then we call this phenomena to be hydrotrophic solubilization phenomenon. Again, I am repeating, when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, then we call this phenomena the hydrotrophic solubilization phenomenon. Okay, let me tell you one thing. Whenever some doubt comes to your mind, whether you are a student or teacher, you please note down your questions at the end of the session. We will have question answer session. And one more thing, in the last, I will share my WhatsApp number to those students or teachers who want to do such type of research, eco-friendly or green chemistry work. They can associate with me for this. Or if you want to take this PowerPoint presentation and so on, so forth, so many things are there. You can connect with me. Okay, if you are a researcher. Okay. Now coming to now we are shifting towards the utilization of hydrotrophic solubilization for replacing organic solvent. Now our aim is going to start. What is the aim? Our aim of this today's lecture is that how can we minimize the use of harmful organic solvent because they are very harmful. So now from here we will start our journey in from the titrimetric analysis, epophenic titrimetric analysis. Here I am going to give one example of furosemide drug, furosemide drug API, active pharmaceutical ingredient. When the pharmaceutical manufacturers they prepare the tablets of furosemide or injection of furosemide, they purchase in bulk 25 kg bag, 50 kg bag, and so on and so forth. Then in that bag it is written that it is furosemide IP. Just by saying furosemide IP, it does not mean it is 100% pure. To find out this drug content, we call it this process to be assay of furosemide. We is to find out the drug content in our API from which we are going to manufacture the tablets or capsule. You have to find out whether it is 99% pure, 98% so on so forth. So as per Indian pharmacopoeia and British pharmacopoeia method, means how do they assay? They perform the assay. So that method is given here. So from that 25 kg bag, you will weigh accurately about 0.5 gram of furosemide API powder. It will be dissolved with the help of 40 ml of dimethylformamide solvent, dimethylformamide. It is a class 2 organism, but what I am saying that you are going to dissolve 0.5 gram furosemide with the help of 40 ml of dimethylformamide. You get a clear solution. This dimethylformamide is very good solvent for furosemide. Furosemide is water insoluble. That's why pharmacopoeia they employ organic solvent for its dissolution. Once you get the solution of furosemide in DMF, means a clear solution, then you add few drops of bromothiamyl blue solution as indicator. We are going to perform a titrimetric analysis with the help of NaOH solution in butyrate like that. So anyway, again I am saying a conical flask, 0.5 gram furosemide API, 40 ml of DMF, clear solution, few drops of bromothiamyl blue indicator. The solution is there in your conical flask. Now in the butyrate, it is 0.1 molar NaOH solution. You start the titration from starting the addition of 0.1 molar NaOH in your conical flask. You are taking it. As soon as color change means endpoint comes, suppose it comes after 20 ml, after 22 ml, you have to note down this reading. Means I will say to be x1 ml of 0.1 molar, 0.1 normal NaOH has been consumed by in this first titration. Are you following me? Okay. Now you have to perform a blend determination. In blend determination, you will take another conical flask and you can clean 40 ml of DMF, few drops indicator, bromothiamyl blue indicator, 0.1 molar NaOH solution you will add. Suppose for color change or endpoint 1 ml or 2 ml of this NaOH solution is required here for color change. So this solution has been consumed by your solvent system DMF. So this will be subtracted from the earlier first titration x1 ml. So suppose this is y1 ml. Y1 means suppose 1 ml. Y1 ml. So this y1 will be subtracted from x1. Suppose x1 is 20 ml or whatever. So x1 minus y1, this difference of volume of NaOH has been consumed by your drug. है ना? Okay. Now using the factor of IP, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. You can find out the content. Okay, so this is the IPBP method. Here you are going to imply an organic solvent dimethyl formamide, which is a class 2 organic solvent. Now I will give the replacement for this harmful organic solvent utilizing the solubilizing power of safe and economic solvent. So now I am discussing this hydrotropic analysis method, hydrotropic method, green chemistry method. So in this method, you will take conical flask, you will transfer 0.5 gram of furosemide API powder from the 25 kg bag. Then you will dissolve this drug with the help of 40 ml of 30% weight by volume sodium dilute solution. You will get a clear solution. Why you will get a clear solution? Due to hydrotropic solubilization, or in other words, you will say the solubilizing power of a solid with sodium value. So again, I am repeating, you have dissolved 0.5 gram of furosemide powder with the help of 40 ml of 30% solution. You are getting clear solution. Then you will add few drops of bronchodilatation indicator, and from the view rate you will run, you will start the addition of 0.1 molar NaOH solution. As soon as you get the end point, say suppose after 21 ml, 22 ml or so, this you have to note down. This is x2 ml of NaOH have been consumed in this first titration. Now you will perform a blank determination. So for blank determination, you will take another conical flask, neat and clean. Then you will transfer in this 40 ml of 30% sodium dilute solution, 2 drops of bromomethyl indicator, you will run 0.1 molar NaOH solution. So suppose for the color change or endpoint, suppose 2 ml is consumed, I will say to be Y2 ml. So this Y2 ml will be subtracted from X2. So X2 minus Y2, this much volume of NaOH has been consumed by your drug. Using the same factor of IPBP, each ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. You can find out the content. Now see what is the difference between these two methods. One is IPBP method. In IP method, what you are doing in IP method, you are dissolving your drug in dimethyl formamide, and all organic solvents they are volatile. This is also volatile. When you will perform the titration, the DMF vapors will go inside your body. Now, on other side, hydrotropic method, sodium dilute sodium dilute solution you are dissolving drug. Then you are performing the English titration. Sodium dilute does not come inside your body. It is non-volatile. It does not come inside your body. Number one. So what you have done, you have replaced dimethyl formamide by solubilizing power of safe and economic solid sodium benzoate solution, which is non-volatile, harmless. Number one. This is main important. Without using any organic solvent, you are going to titrate your drug. Number one. Number second advantage is that the sodium benzoate solution is very economical. Nearly in 100 rupees, nearly in 40 rupees, you can have 1 liter of this 30% sodium dilute solution. Again, I am repeating, rupees 40 is the cost of about 1 liter of 30% extra solution of sodium dilute. So economic also. Otherwise, other organic solvents, ethanol, formaldehyde, pharma, 200, 300 rupees per liter is also. So our method is economic, but I give much importance on the method without or involvement of organic solvent. Means you can prevent your human society from the ill effects of vapors of this harmful organic solvent dimethyl formamide like this. So this is the main aim. So again now, so what you are listening that we can replace an organic solvent which is being employed by pharmacopoeia by safe and economic solid sodium benzoate solution like that. If you have any question, note down the question. Now, another example is that of flurpropyl API, similar to Cruiser. For the IPBP method, flurpropyl is dissolved with the help of ethanol, as you are seeing in your slide, ethanol solvent. And then NaOH is used for its titration analysis. What I have done, I have estimated this by titration method using 30% sodium benzoate solution. So what I have done, by sodium benzoate solution, I have replaced ethanol. Ethanol is class 3 organic solvent, but then also it is harmful. Without organic solvent, just by use of hydrotrophic solution, a solvent system, they are going to perform the cytometric analysis. Third example is that of naproxen API. Naproxen, the method of IPBP, it involves the use of methanol as you are saying on your slide. Cytometric analysis, anyway, methanol, it is dissolved with the help of methanol plus 2 organic solvent. Now the same thing has been done by me using sodium benzoate solution, hydrotrophic solution. Dissolution of naproxen in sodium benzoate solution and then titrate. So we have replaced a class 2 harmful organic solvent methanol by a safe and economic sodium benzoate solution. Now coming to salicylic acid, this can be done in all colleges. The salicylic acid is there. So I am briefly discussing this method. And when I do perform, when I conduct the workshops in colleges personally, physically, then I demonstrate this also, the titrimetric analysis of salicylic acid. So let me discuss first this IP method. This salicylic acid is a poorly water soluble drug. So IPBP, they suggest the use of ethanol as you are seeing on your screen. The 300 milligram of salicylic acid is dissolved with the help of a mixture of 20 ml water and 50 ml ethanol. You get clear solution, then phenolphthalein is added and titration is performed and carry out a blend determination. Now, in hydrotrophic method, we dissolve the sodium salicylic acid with the help of sodium citrate solution without ethanol. Without ethanol. So, in this hydrotrophic method, what do? We do dissolve 300 milligrams salicylic acid with the help of 25 ml of 30% sodium citrate solution. This is another hydrotrophic agent. Sodium benzoate we have used so many times. Now this is the sodium citrate, which is a good hydrotrophic agent for salicylic acid. So again, I am saying, what do? You dissolve 300 milligrams salicylic acid with the help of 25 ml of 30% midwiver in sodium citrate solution. You get clear solution. Phenolphthalein, few drops are added, and titration is innovation. Blank is determined is done as I have discussed previously previous examples also. So ultimately, what you have done, you are titrating with the help of sodium citrate solution. Sodium citrate is non-volatile; it does not go inside your body, and of course, the cost wise also nearly 40 rupees per liter is the cost of sodium citrate solution in our. So always what you are observing here, without organic solvent, just by use of hydrotrophic solutions, you are performing the titrimetric analysis. Ketoprofen API, here ethanol is used for the dissolution in IPBP method. Now, in hydrotrophic method, we have employed sodium benzoate solution. Coming to ibuprofen API, involvement of ethanol in IPBP method, we have replaced it by sodium benzoate solution in the usual manner. Now, one more this essay I will discuss here. IPBP method for the ibuprofen tablets to find out the drug content. It involves the use of two organic solvents, chloroform and ethanol. So the tablet powder is taken with chloroform. Chloroform is class 2 organic solvent, and it is good solvent for this this ibuprofen. So ibuprofen gets dissolved and it comes in solution uh, with the help of chloroform. Then IPBP, they say that chloroform to remove the chloroform and air current. When most of the chloroform is evaporated out, you get a residue, and that residue is dissolved with the help of ethanol. This is another solvent, second solvent involved in IPBP method. After dissolution uh, this moss, semi-solid moss in ethanol, residue in ethanol, then naphthalene is added and titration is performed. Ultimate content factor is given each ml of 0.1 molar and it is equal to this much of this. You can find out the drug content. So here again, let me brief that in IPBP method they utilize two organic solvents, chloroform class 2 and ethanol class 2. Now we will do without these two organic solvents by hydrotrophic. In hydrotrophic method, what you will do, you will transfer the tablet powder in a conical flask and then you add 100 ml of 30% sodium benzoate solution, hydrotrophic solution. Sodium benzoate solution has got very good solubility of sodium benzoate with the help again the same sodium benzoate molecules they come in liquid state for chemical and all that anyway. what you are doing, 10 minutes briskly you have to shake the tablet powder with the 30% sodium into your solution. Then naphthalene indicator added and 0.1 molar range is used for cytometric analysis. And then you perform the factor of this uh, the same factor of IPBP is used to find out the drug content of your ibuprofen tablet. This is the procedure. Now the difference between these two methods. Let me take some date on this one. Oh, okay. Okay. So anyway, so in this way, what you have done with the help of sodium iodide solution, two organic solutions, they have been replaced. Now, after type analysis, now coming towards the UV spectrophotometric analysis. Here in spectrophotometric analysis, again, now we will replace orthoorganism by hydrocarbon solution. So briefly, let me say the assay of indazole tablet as for Indian pharmacopoeia or British pharmacopoeia method, they are same. So here, what do they say? Means 20 tablets, their weight, average weight is determined. Then tablets are powdered, then they are sieved through sieve, and after the sieved powder, you take such a quantity as for I3 method, which contains 0.15 gram of indazole. It has been transferred in a 100 ml volumetric flask. Then you add 20 ml of methanol, and then you shake it for sufficient time. So during this shaking, methanol dissolves the indazole present in the tablet powder. Then IP says that you have to make up the volume up to 100 ml with methanol. Then from this, since it contains filtration, then you take 10 ml of filtrate from this, and it is diluted up to 100 ml with methanol. And then from this again you take 10 ml, further you have to dilute it 10 ml and dilute it up to 100 ml with methanol. Then the absorbance of this solution is noted at 310 nm, 310 nm against. So the same. In both covered, methanol is same. So then the effect of each other is neutralized. Only the absorbance comes due to a drug. Then after absorbance, then using the factor, this 356, even 1%, 1 centimeter of specific absorbance, you can find out the drug. Let me say in brief, what you have done, you have utilized methanol, last warning solvent, in IPPP method. Now, without methanol, we will perform the same cytometric UV analysis. Now, in hydrotropic method, what you will take? You will take a 25 ml volumetric flask, transfer such a quantity of powder which contains 50 milligram indazole tablet powder has come here in a 25 ml volumetric flask. Then you add 20 ml of 30% sodium benzoate solution, hydrotropic solution, and 10 minutes briskly you have to shake it. During this 10 minutes shaking, the sodium benzoate solution or hydrotropic solution will dissolve the indazole present in the tablet powder. Then further dilution is with water, not with sodium benzoate solution, with the water. So up to the mark and means 25 ml, it will be diluted with water. So now total volume became 25 ml. Now we have to filter this because it contains water-insoluble tablet excipient, so we have to filter it. After filtration, you take 1 ml of the filtrate and dilute it up to 100 ml with water, not with sodium benzoate, with water. Then absorbance of this solution is noted at 318 nm, 318 nm, 318 nm, because in water the peak of indazole comes at 318 nm, in methanol peak comes at 310 nm, 310 nm, here 318 nm. So this is due to change in solvent character. So now again let me tell you what you have done. Sample covered you have put the sample solution, in reference you have to put reagent blank solution. So in this hydrotropic method, so how you will prepare this reagent blank solution? Again, now I am saying the procedure to make reagent blank. You will take another 25 ml volumetric flask, transfer 20 ml of sodium benzoate solution 30%, dilute with water up to the mark 25 ml. Then from this you will take 1 ml and dilute it up to 100 ml with water. So this is the reagent blank solution. This will be kept in the reference cupboard. And why it is reagent blank? In both solutions and sample in which the drug is also their sample solution and reagent blank. Concentration of sodium benzoate is same. That's why the effect of it is neutralized, and whatever the absorbance you note at 318 nm, it is due to your drug. So what you have done, you have noted the absorbance of this solution at 318 nm. Now here in this slide, you will not find E1% 1 centimeter. I have not given specific absorbance. So when you carry out, I can send the full procedure to you if you want to carry out this work in your lab. Teachers as well as students, I am telling all of you. Anyway, now let me explain this thing now again to you. That what you have done, you have noted the absorbance of this unknown sample. Now to find out the drug content, what you are going to make one calibration curve. Calibration curve. So for calibration curve, you will take pure drug sample. Pure drug sample means the sample which you obtain from company or you purchase either you get gift sample on that it is written in the it is the drug content is 99% for example. So based on that drug content, you will weigh 50 milligram of indazole pure drug sample. It will be transferred in a 25 ml volumetric flask. You will add 40 ml of sodium benzoate solution, sorry, 20 ml of 30% sodium benzoate solution. You will shake it in 25 ml volumetric flask. You will get clear solution due to hydrotrophic solubilization. Then up to the mark with water 25 ml. So now this is the stock solution 25 ml, which contains 50 milligram of drug. 50 milligram per 25 ml means 2 milligram per ml. 2 milligram per ml means 2000 microgram per ml solution, stock solution is ready. From this stock solution, you will prepare different standard solution. If you take 1 ml of the solution, dilute it up to 100 ml with water, it will be 20 mg per ml solution, standard solution. And for this reagent blend will be made in the same way as we have discussed. So 20 mg per ml solution, stock solution here, sample solution, and here you have put the reagent blend solution. Absorbance is being noted at 318 nm. Similarly, you will make for 5, 10, 15, and 25. Only thing you have to remember is you will have to take respect to reagent blend. They will be different for different dilution. So in short, let me tell you 5, 10, 15, 20, 25 mg per ml standard solutions. They are absorbances at 318 nm using these absorbances. Absorbance value you can plot a calibration curve. Then that calibration curve y is equal to this much x and all that. You can find out the drug content in your tablet. Now important thing to understand here. What you have implied here, sodium benzoate solution, hydrotrophic solution. Sodium benzoate does not go inside your body. It is economic as I have told you. Okay. So you have replaced by hydrotrophic solution. What you have replaced? Methanol of class 2 organic solvent which is used for IPBP method. Okay. Number 2. Sodium benzoate does not interfere in UV estimation above 292 nm. Means, in other words, you may say the cutoff point for the sodium benzoate is 292 nm. Above this, there is no absorbance of sodium benzoate, so there is no interference at 318 nm. Okay, so if you want to carry out some new work, always keep it in mind that you select such a drug which has got peak, at least one peak away from 292 nm, so that you can utilize sodium benzoate in hydrotrophic. But anyway, so many things are there. So those who want to take more interest, they can contact with me, and then I will tell you all these things. One more thing, let me tell, because the teachers are also there, they should understand how this cutoff point was known. So what did I do? I made a strong solution of sodium benzoate in water, 2000 microgram per ml in water, 2000 microgram per ml sodium benzoate solution. It was kept in sample cavity in reference water. I observed the scan. So from your point, from your side, if you see from 200 to 400 nm, the absorbance of sodium benzoate ends at 292 nm. Above 292 nm, there is no absorbance. That's why the cutoff point of sodium benzoate is 292 nm. So anyway, a large number of drugs they have been estimated using sodium benzoate and so on and so forth. Now, suppose your question is there that Suppose your drug has got peak before 292 nm, suppose 270. I'm giving one example of atenolol tablet. Atenolol tablet, the peak of atenolol comes at 275 nm, 275 nm peak of atenolol. Okay. And the IPBP method, they say to utilize methanol. They are using methanol for its estimation. What I have done, I have used a urea solution. Concentrated solution of urea was employed as hydrotropic solubilizer or hydrotropic solvent system to carry out the UV spectrophotometric analysis of atenolol tablet. And it was estimated at 275 nm. And the cutoff point for this urea is 240 nm, and so on and so forth. Anyway, uh, now coming to the TLC. These TLC, they can be done in B for final year program, B for third year student, they can also do. Means the third analytical method, one titiometry, UV analysis, and third is titiometry. So we can perform the TLC of compounds without organic solvent. Up to this time, you see the TLC, that mobile phases compositions, always one or more than one organic solvents are there. But in this particular study, you will find the hydrotropic solutions were employed, which were not having organic solvent. Very simple thing and very economic. And such type of projects can be nicely handled by the B Farm student. Now here, I will give one example of one published paper. Three M Farm students were giving this work. As you are seeing the title, it is before you. Okay, without organic solvent, you are performing the TLC. What has been done in this particular project? Uh, 9 water-soluble drugs, 9 were given to 3M for students. Out of those, 9 water-soluble drugs were there. What I want to say is, if you want to see their IP method of these 5 drugs, ciprofloxacin hydrochloride IP method or TLC, there is involvement of dichloromethane, methanol, acetonitrile. These three class 2 organisms. Guaifenesin drug IP method, carbon tetrachloride and ethanol. Okay, so you will find one or more than uh, which organic solvent is volatile. They go inside the vapors go inside your body. Now today you will see that without organic solvent you will perform the PLC. How? So firstly, let me tell you what was this project. I told the 3M for student. I gave 9 water soluble drugs, and for each drug I told to carry out the TLC with 8, 7 plus 1, 8 blends. And the compositions of these blends were what? Without organic solvent. Blend 1, aqueous blend, sodium benzoate 5%, sodium acetate 5%, total is 10% aqueous solution was used in mobile phase to carry out the TLC. Blend 2, 5% sodium benzoate, 5% niacinamide. Blend 3, 5% sodium benzoate, 5% sodium citrate. Blend 4, 10% sodium benzoate. Like this. 8 blends were used for each drug. And then I told the student to carry out the TLC. Uh, these aqueous solutions of hydrotropic agents were employed as mobile phases. Okay. So let me tell you briefly the full procedure. 2% aqueous solutions of drugs were made to put the spot with the help of capillary tube on silica gel G plates. Silica gel G plates. Spots were put. Then you have to remove the water. So these plates were kept in oven at about 60-70 degrees centigrade for the removal of water. Now your spot is there, that of your drug is there on your silica gel TLC plate. Then this plate was developed with the mobile piece, hydrotropic blends. 8 blends were used for each drug. Say for example for vitamin B1 hydrochloride, as you are seeing number 6, B1 hydrochloride. 8 blends means 8 TLC were performed. I told the student that you select such a hydrotropic blend or mixed hydrotropic blend which gives peak without tailing effect. If tailing effect is there, you forget about that solvent system. You forget about that blend. But if you get a spot without taking effect, you note down its RF value. As you are seeing on a screen, for vitamin B1 hydrochloride blend 2, the composition of this mobile phase was sodium 5%, glycerol 5%. So then, now it was done to B2, mobile phase. After development of the plate was removed after development, and then it was kept in the oven for the removal of water. When it was dried, it was kept in iodine chamber for spot identification. Iodine chamber for spot identification. One thing you should listen carefully. You see, when this plate will be dried in oven, sodium benzoate and niacinamide, they will not be volatilized out. They are non-volatile. So they will remain on the slide itself. They are still there in slide together with the drug spot. Now, when you keep the slide in iodine chamber, the slide is slightly yellowish because throughout the this plate, sodium benzoate and niacinamide they are there. So they will also absorb iodine. So because of this slightly yellow color will be there, but wherever there will be the your spot of say vitamin hydrochloride, it will be intensely yellow colored. Anyway, so in this way, two blends were found good, blend 2 and blend 4. Remaining 6 blends were not suitable to carry out the TLC of this B1 hydrochloride. So in this way, these, as you are seeing in the case of 9 number 9, low salt and potassium, blend 1, 3, 4, 6, they were found suitable. Remaining 3 blends were unsuitable like that. So just by permutation combination means you will have to prepare different solvent system of different composition. They will be tried for your drug, and then when you get a spot without taking effect, then that will be selected for your drug. So now, anyway, now in PLC, let me explain you. In PLC, what happens? There are three operations: adsorption, partitioning, and solubility. Our system acts on solubility basis. Means here the strength is 10% because your water soluble drug is there. So for water soluble drug to carry it away, a small concentration of solubilizer is enough to carry it away. Suppose there was water soluble type of drug, then maybe that 10% would not have sufficient strength or solubility that it can run it to sufficient height. So for that, more is the concentration of hydrotrophic agent, more is the solubility. So for to carry out the TLC for water soluble type of compound, you will have to select say 20% or 25% or 30% mobile phases to carry out the TLC like that. So anyway, now you listen one statement from me that for each and every compound which are present in your stores, in your college, you can select three, four those compounds, and of those compounds you can perform the TLC without the use of any organic solvent. And then after doing this work, it should be published also so that the researchers of this world they will see that without the help of organic solvent also you are able to perform the TLC of the compound. Now there are two things. If the selected compound is water soluble, then small concentrations of mixed hydrotrophic solutions they are enough. 8%, 10%, 12% to carry out the TLC. But if your compound is water soluble type, then you will have to take more concentration, means 20%, 30% of hydrotrophic agent so that it can be carried out upside like that. So in this way. But for each and every compound, TLC is possible without the use of any organic solvent. If you have any question in your mind, please note down your question to the answer. So, level of the student second year, third year. So, HPLC, I am just very briefly I am going to discuss because teachers are also here in this particular session. So here I will discuss the work of this Remy SL Madam. Third line. Remy SL Madam is the author of this paper. She has done this work. What she has done, cefixime tablet have been analyzed by Remy Madam using 6% aqueous solution of sodium acetate as mobile phase without any organic solvent, no acetonitrile, no chloro, methanol, ethanol, etc. So, have been estimated by Red Madam using reverse phase HPLC, and of course he has utilized 5% urea substance mobile phase to carry out this particular reverse phase HPLC. Now, one sentence is listen from me that uh, for if you want to carry out such type of work, reverse phase HPLC of compound, then you should select water soluble drug. Do not select water insoluble compound. Select water soluble. If you select water soluble drug, a large concentration of hydrotrophic agent cannot be employed as mobile phase to carry out the reverse phase HPLC, otherwise the columns will choke. So again, you listen my sentence. Forget about the water soluble drug by HPLC. Select water soluble compound and you perform the reverse phase HPLC using 3% sodium acetate solution, 2% sodium acetate plus 2% sodium benzoate solution. Permutation combination of these different compositions of these. If you take 5, 6 blend, definitely you will get success for your compound. One more thing, let me tell you, those who are interested to carry out this reverse phase HPLC, I can send you the list of about 200 water soluble drugs. From that list of 200 water soluble compounds, you can select anyone whichever you are having, and you can perform the reverse phase HPLC without the involvement of any organic solvent. There's such types of works should be published also, so that the researchers of the world they can see just by use of solubilizing power of solids, you can perform the reverse phase HPLC. So anyway, so many things were there. Now coming to where it means 15 minutes more, I will take to discuss some more things. I told you that hydrotrophic solubilization is more than 100 years old concept. More than 100 years old concept. Okay. No one has employed mixed hydrotrophy before 2008. And in 2008, from our India, the first papers they were published on mixed hydrotrophic solubilization. Now the thing is that why mixed hydrotrophy has been started. The reason that let me give the example here. With example, I will discuss this thing. Now see, this is a table containing various concentrations of different additives which are employed to make aqua intramuscular injection. First, you please read this title as per Inactive Ingredient Guide 2009 10 additives for aqueous intramuscular injection. Now, this Inactive Ingredient Guide it is a thick book. It gives this book is referred by pharmaceutical manufacturers. What is given in this book? In this book, the different concentrations of various additives is reported in this book. Means in topical solution, how much percentage of particular additive, how much percentage of additive in injection, in topical solution, syrups, and so on and so forth. It is given in this thick book. From that thick book, I have brought these concentrations of additives for you. These are the additives which are employed in these concentrations. They are safe. Safe means they are non-toxic. Non-toxic. Say, for example, ethanol, 10% is safe in 8% of injection. Sodium citrate, 10% is safe, like that. So these concentrations of additives, they are safe. Now you listen me. The hydrotrophic solubilizers from 100 years, a large number of published papers you will find. They have prepared even the aqueous intramuscular injections of poorly water soluble drug that are made with the help of say 30% sodium benzoate solution, 30% sodium salicylate solution. These high concentrations of hydrotrophic agent may prove toxic. Means single hydrotrophy may prove toxic. That's why from 100 years, large number of papers they are published, but such work or such intramuscular injections they are not found in market. Because if you are employed 30% sodium benzoate, it cannot be used in aqueous intramuscular injection. Together with your drug, you are injecting a large concentration of sodium benzoate. Anyway, so in this way, let me tell you, that's why the single hydrotrophic solubilized aqueous intramuscular injections could not be marketed. Now I will tell you mixed hydrotrophy, which I started first in the year 2008, and I means three important students they were giving projects on mixed hydrotrophy, and I will give one example here. You see this among this list you will find number 13. It is sodium benzoate. You see these all additives they are safe in these concentrations. So 10% sodium benzoate is given in that intramuscular book. The pharmaceutical manufacturers have employed 10% sodium benzoate as buffering agent in aqueous intramuscular injection. This means 10% sodium benzoate is non-toxic in aqueous intramuscular injection. Okay. Similarly, number 8, sodium acetate. Number 8, 10% sodium acetate. It is safe, non-toxic in aqueous intramuscular injection. Number 2, sodium citrate. 10% it is safe, non-toxic. Now, if you so means in these concentration, these additives you can employ in aqueous intramuscular injection. If you combine these three, sodium acetate 10, sodium citrate 10, sodium acetate 10, 30% solution is ready. In this 30% weight by volume solution of 3 hydrocarbon, the solubility of drug, if it is enhanced to the desired level, you can make its aqueous intramuscular injection, and that can be marketed also. Now, because you are implying 3 hydrocarbon agent in safe means non-toxic concentrations, and you can make now the marketable formula. Okay, so this is the basis of mixed hydrotrophic solubilization. So this can be used to make marketable formulations of aqueous intramuscular injection. When paper was published on mixed hydrotrophy in the year 2008, one Dr. Hussein Misri of Egypt, he has also done work on mixed hydrotrophy, and still he is using mixed hydrotrophy to develop marketable formulation in Egypt and all that. Anyway, so this was about the mixed hydrotrophy solubilization. So particularly mixed hydrotrophic solubilization is not only it is useful in formulations, but also it is used to analyze the drug for their synthesis and for so many things that can be employed mixed hydrotrophy and all that. Anyway, now from the same table, I will explain the second parameter of mixed solvency concept. Again, I am repeating mixed solvency concept, which was proposed by me in the year 2009, first time in the world. There are two parameters of this mixed solvency concept. Number one parameter says that each and everything presented is universal solubilizing power. Each and everything, gas, liquid, solid, all molecules, they are known as solubilizers in this concept. All molecules possess solubilizing power. Only thing will be whatever the name of any solubilizer you take. Say suppose they say CO2 solubilizer, good solvent for combat purpose. Ibuprofen solubilizer, good solvent for combat purpose. Like that. Anyway, now the second parameter of mixed solvency concept is this, that since each and everything has got solubilizing power, this means whatever the additives you are going to imply in your different pharmaceutical formulations must possess solubilizing power. Okay, so again I am now again you give attention on this particular slide. Again, let me repeat what is this slide. This slide gives the safe concentrations of various additives. Safe concentration is which are non-toxic. Safe concentrations of different additives which are employed in aqueous intravascular injections of drugs and all that. It has been brought from electroengineering guide book, which is referred by pharmaceutical manufacturers. So again, let me tell you, these are the additives which are employed to make aqueous which are involved, which are employed in aqueous intramuscular injection. So this means they are safe in these concentrations. From this small table, you can make innumerable safe solvent system, innumerable. You see, up to this time, pharmaceutical manufacturers of aqueous intramuscular injection, they employ water, ethanol, water, ethanol, glycerine, propylene glycol, PG400. Sometimes they mix cyclodextrins. Sometimes they mix twins and so on and so forth. Here the light has gone, but anyway, this is running. So my photo will not be there, but you can see this. Now you see, so these limited number of safe solvent systems are there for the manufacture of aqueous intramuscular injection. But today I will tell you for these pharmaceutical manufacturers that they can make innumerable safe solvent system using the solubilizing power of additives which are employed to make aqueous intramuscular injection. Innumerable, I am saying the word. Okay, so for example, if you make one solvent system using ethanol 10%, sodium citrate 10%, arginine 10%, 1, 2, 3, item number 1, 2, 3, 10%, 30% solution is ready. This is one solvent system. If you change arginine by histidine, if you replace, another solvent system is ready. So just by permutation combination, you can prepare 30% solution, you can prepare 25% solution, and then you check the solubility of your drugs. When you get a good solubility of your drug, you can convert it into aqueous intramuscular injection. So in this way, you can make innumerable safe solvent system to develop aqueous intramuscular injection. Okay. Now coming to the brief idea about the mixed solvency concept, which can be employed particularly when you will take some MPAR projects, pharmaceutics particularly. So very briefly, I am telling them. Dry powder injection for reconstitution of poorly water soluble drug can be made with the help of mixed solvency concept. In this whatever I am going to discuss, they all are MPAR projects done here, and the published paper are available online. And of course, the soft copy of thesis, those who require, whether you are a student or teacher, I can send to you so that step by step you can see how the work should be done using mixed solvency concept. So let me go very briefly here that the MPhil student has employed candicertan selexatin 8 milligram, which is the dose of drug. It was solubilized with the help of three solids: sodium caprylate 100 milligram, benzoate 50 milligram, and acetate 50 milligram. They were kept in wild. When you add 1 ml water and reconstitute, you get a clear solution. So these all are available. You can ask me. Solid dispersions can be made with the help of mixed solvency concept here in this particular MPAR project. Torsemide drug was dissolved with the help of these four solids. Such type of projects can also be done by B.Pharm final year student. Oh, anyway, so now solid dispersion for postularies. Liquid solid system, they can also be developed for poorly water soluble drug. Here, non-aqueous solvent propylene glycol was used to make the liquid solid system of pyroxicam. Solubility of pyroxicam was improved in propylene glycol with the help of mixed solvency concept using the solubilizing power of sodium caprylate and sodium acetate, and then the liquid solid system was adsorbed on with the help of adsorbent to make free flowing, and then of course it was converted into tablet or capsules and all that. Aqueous injections, they can be made with the help of mixed solvency concept. Dry powder injection for aqueous, this is another work, published paper online available, and it is available with me. And then coming to the use of mixed solvency concept to develop vaginal film. Here the metronidazole solubility was improved with the help of solubilizers, and the size of vaginal film was reduced. Improvement of drug loading in ACDDS, reducing the size of concentration of sodium this surfactant and co-surfactant. Improvement of drug loading in oral film, and hence the size was reduced. Then again the dissolving oral film size was reduced with the help of mixed solvency concept. Then of course this is also one more interesting thing for you. These things can also be taken as VFARM project and all that. Now let me tell you how the solids can be employed, because particular in this particular lecture what you are listening from me, the solids can also be employed for their solubilizing power. So in this particular published paper, 5 M4 students were given this project, and as you are seeing the title of the published paper, eco-friendly extraction using solids, a novel application of mixed solvency concept. Published paper reference is there. What was done here? Let me tell you. M5 M4 students were given this project. Sesame oil was selected as active constituent, which is found in sesame seed powder. Then briefly, I will tell you how the extraction was done. So firstly, we purchased the marketed sesame oil, and the solubility of that sesame oil was checked in melted thymol. In a test tube, 1 gram thymol was taken, and it was kept on water bath. 50 degree is nearly 50 degrees is the melting point. So at 50 degrees centigrade, you are having clear colorless melted thymol liquid, in which the molecules of thymol they are in liquid state. Anyway, now in this 1 gram clear colorless melted thymol liquid, 0.1 ml sesame oil was added. It was dissolved. 0.1 ml sesame oil again dissolved. More than 1 ml of sesame oil is nicely dissolved by 1 gram melted thymol at 50 degrees centigrade. Now extraction was done. 3 grams sesame seed powder in a test tube, 3 grams sesame seed powder, 9 gram thymol, water bath, thymol at 50 degrees centigrade. During this melted condition of this thymol, the test tube was shaken, again heating, again shaken like 30 minutes shaking. During this 30 minutes, melted thymol dissolved the sesame oil present in the sesame seed powder. Then this was strained through cloth. So strained liquid containing melted thymol containing dissolved sesame was kept in fatty dishes, etc., or watch glasses in oven at about 60-70 degrees centigrade for the removal of thymol. Remaining was sesame oil containing some traces of thymol, of course, but of course, it is not a refined paper, but it gives some idea that solids can also be employed for the extraction. Similarly, if you see number three, ethanol is poor solvent for sesame oil, but when 50% thymol was dissolved in ethanol, it became a strong solvent and it was employed for extraction at room temperature. I mean, all this you will find in the published paper. And anyway, coming towards the end, let me tell you, I have made seven YouTube videos, each of about 40 to 45 minutes duration. If you put these words, eco-friendly lecture series number one, it is for UV spectrophotometric analysis of poorly water soluble drugs by application of hydrotrophy mixed hydrotrophic mixed solvency concept without the involvement of organism. 40 to 45 minutes duration. Please, you can see at your home. Eco-friendly lecture series number two, it is for titrimetric analysis of drugs without organic solvent. Eco-friendly lecture series number three is for mixed solvency concept. Each and every substance, whether gas, liquid, or solid, present in this universe has got solubilizing power. 40 to 45 minutes duration. Next, eco-friendly lecture series number four, it is for TLC. You can see at your home, TLC. Number five is for reverse phase HPLC. Number six is for dry powder injection for reconstruction, pharmaceutics work. Number seven is to make innumerable eutectic liquids. The teachers or researchers who are interested to make eutectic liquids for what? Analysis, synthesis, formulation, and so on and so forth. It is an art. You will not find in your book these things, any book. You see this YouTube video to have this art. You can make innumerable eutectic liquids. Okay. Now coming to four. Okay, one. Acha, okay, now my lecture is nearly over, and of course, here one thing is important, that is my WhatsApp number. Those researchers or the students or teachers who want to connect with me, they can put on this WhatsApp number. And now I am coming to you for to give the answer for your questions. And let me tell you one more thing. In starting, I could not give the thanks to the management of your institute, because of whose effort I am here with you to discuss these research ideas. So I am thankful for all such, Mrs. Savita Madam and all that, the principal and all, for the management and all that, to for this particular webinar. So uh, let me call to student to reduce this, and then I am coming to you for answering your question. Let me ask by poll.